Okay, Ruofan, will you please start?
So hello everyone. Today I will present the paper titled Recall a Case Surrogate Loss with Large Batches and Similarity Mix-Up. So these are the authors for the paper. They are from the SAC Technical University. First author is a PhD, second is an assistant professor. Last author is the professor. They have common research interests in computer vision and image retrieval. So this paper is on metric learning. In short, metric learning is trying to learn a low-dimensional metric space such that instances from distinct classes can form distinct clusters. And the mapping from the original data space to the metric space is usually done through a deep neural network. So you can see metric learning is very similar to classification, because both would like to make their inter-class distance as large as possible. However, in classification, it is not able to generalize to new classes that are not seen in the training set, because remember the output layer in classification, which is a softmax layer, has a fixed dimension. So we have to know the number of classes in prior to training. But in metric learning, it can work even on unseen classes, because anyway, we are only learning a function to project onto metric space, and we are not doing any classification.
I have a question here.
Okay.
So the figure here seems like the dimension reduction problem. So they have some similarities.
Yeah.
I think. So with the methods from dimension reduction, can those methods be used for metric learning? Is it possible?
But for dimension reduction, it's supervised or unsupervised?
Unsupervised.
Unsupervised. For metric learning, it's still supervised, because we need to know the class label.
Oh, okay. But is it possible, like, to integrate the strategies from dimension reduction into this metric learning? No, I'm not sure. I just feel that there are some similarities here.
Another comment is that if we look into the dimensional reduction or just Xiangling DBI visualization techniques, so basically, I think the commonality lies in all the techniques, or both techniques, just project the high-dimensional space vectors into low-dimensional space vectors, and the projection must conform to certain property, right? So for Xiangling's work, you want to the neighbor preserving property be preserved. And for Ruofan's metric learning, so basically they want to the property that the class, the samples fall into the same categories, for their distance will be closer than or smaller than that of the samples from different clusters. And but for Xiangling's, but for the visualization, dimensional reduction for visualizations, I think the optimization information, all the information for optimization is more enriched. You think about it, because you have already now the distance between the high dimensional vectors. But for
so are you saying that in the original data space, they are
I'm saying
you
that for
cannot
metric, I think for the metric learning, it is the data set is less informative than the dimensional reduction, because for the dimensional reductions, the distance between the high dimensional vectors is none. But for Ruofan's metric learnings, they only know these two high dimensional vectors are of the same category, but how close they are, and we miss information for how close they are.
I think we still know the information, but we didn't use in metric.
Yes. So my point is that maybe apart from the current method, if you can like somehow use some hybrid between those two methods, would the
Ruofan,
result be better?
sorry, so I understand Charlie proposed a
Mm.
hybrid technique, but for Ruofan saying that the dimension, the information is there, it does not miss that the information. Ruofan, can you elaborate more on that part?
Because you already know the original data, you know the image, right? So you can compute the distance between any pairs of images. But in machine learning, we just didn't.
But the point is that we do not know whether two images, how close these two images are. For example, we know that a cat and a dog, right? We know a cat and dog are of different category, and a cat and a car are also of the different category. But based on the labels, we do not know how far they are.
But based on the image itself, you can calculate the distance between them.
You mean the Euclidean distance about the two images?
Yeah.
Do you think it's reliable?
Oh, but in dimension reduction, you do this, right? So in fact, in dimension reduction, you just calculate the Euclidean distance in original data space. Then why do you think it's not reliable?
But the point is that if the high dimensional, so I think the assumption that the assumption of Chinese work is that the high dimensional, the distance between high dimensional vectors makes sense, right? So if we just using the Euclidean distance of two images, we do have a distance of the high dimensional vectors. Basically, there's Euclidean distance about Euclidean distance of two images. But this distance, is that distance enough for a guidance for training?
But again, in dimensional reduction problem, you only compare the image. You only look at the local region for any images. I mean, for far away, for two images far away, you don't just use Euclidean distance.
Yeah, the point is that is there?
So here we just assume in local region you can approximate any distance.
Okay. So if I raise I understand. So if I raise examples, if a cat and dog share different background, but a car and a cat share exactly the same background, and how close? I think, and there's the distance close, the close Euclidean distance, not necessarily mean the close semantic distance. Right, and that distance may lose. I think you make a point, being that the distance might be useful, but I think the key difference or the critical point is that when we are conduct the dimension reductions for visualization, the high dimensional vector, the distance between high dimensional vectors is reliable. But when we only have images as the raw high dimensional vectors, and their distance may or may not reliable. So I think that's the key difference. Okay, so any questions for that? If there's no questions, so maybe we can keep going on.
So since the goal of metric learning is to learn a low-dimensional metric space, such that instances from different classes are far apart, a natural way of designing laws is like this. So given a random instance, we call it anchor. We will select an instance from the same class and an instance from a different class, and we try to minimize the green distance and maximize the blue distance. So this design of laws is usually called pairwise laws or triplet laws. But the problem of using pairwise laws is you have to iterate through all combinations of pairs and triplets, which is unrealistic. So you need to design some smart way to subsample some informative pairs or informative triplets to train. To avoid the need of designing such a complicated sampling strategy, researchers have introduced the notion of proxy, where we assume that there exists some pseudo-embedding. They are not coming from the dataset, it is jointly learned with the model. So each of the proxies is a representative embedding for each class. Then given a random instance, instead of selecting some other instance, we just need to minimize the distance between anchor and the corresponding proxy, while maximize the distance to other proxies. So that will save the computational efforts. And these two categories of metric learning is still focusing on designing some laws to achieve the goal. But the third type of metric learning is to use some advanced training tricks. For example, we generate some synthetic proxies by using linear interpolation between the available proxies in your data, or generate some synthetic samples by using the samples in your data. And you hope that this synthetic class will mimic the distribution of your testing set. And the paper I introduced today actually falls neither into the three categories, but it's still a work on introducing some new kind of laws. The basic idea is it designs a laws based on the evaluation metric. That is what you evaluate, then how you train. Let's take the proxy-based loss as an example. During training, the loss is like this. Suppose X is the embedding for a random instance, and we recognize the loss has a log exponential structure, so you know we are trying to use some cross entropy like loss. And then we will maximize the numerator. The numerator is the cosine distance between X and the proxy for the corresponding class for X. So the loss is basically trying to model the data proxy relationship. But the metric we are evaluating is actually different from the loss. We use recall at K as the evaluation metric. Given a query image, suppose it is Q, and we will find its Q nearest neighbor in the gallery set. So this gallery set is usually the test set. Recall at K is defined as the numerator is the number of samples in the K nearest neighbors that have the same class label as Q. And the numerator is the number of samples in gallery set that have the same class as Q. So here is an example. Suppose this is Q, and we find its three nearest neighbors. So these are the nearest neighbors. And then there are in total 1, 2, 3, 4, 5 instances in the full gallery set that has the same label as Q. Then I raised a question here. So what is the value of recall at 3? Maybe Mengyue, can you answer this question?
Maybe can I write? There are two samples. There are two samples, and there are 5 samples, so it should be 0.4.
Oh, sorry. This should not include the Q itself. So we should only look at its neighbor. So
so
it's
0.12, right?
Yeah.
1 of 5.
Okay.
Hello.
Yeah. Okay.
Thank you.
So this is just an example.
Wait, Ruofan. So, so can you be more specific on the PQ? The PQ is a gallery set is a test case, right?
Test set. Yeah.
Is a test set, and how about the numerator? The numerator is for the training set.
Numerator is also in the test set.
Okay, so that's just a metric set for just for the test case, but the same metric can also be applied on the training set.
Yeah. So this gallery set can be any set you want to evaluate.
Another
So-
question.
Oh, please.
No, I just want to ask, the loss itself, you mentioned that X transpose times WY is cosine similarity, and why is that?
With the
Oh.
proxy?
This X trans.
Yeah, X transpose times, why is it cosine similarity?
So actually, this X and W here are L2 normalized. So this inner product can be seen as the cosine similarity.
Oh, okay.
The original formula for cosine similarity is it has to be divided by the
Oh,
L.
I know. Okay.
Yeah.
Well, by the way, so
Mm.
here I would like to clarify that both WC and WY are proxies, right?
Proxies. Yes, but this is the proxy for the ground truth class.
Mm.
And this is for single proxy.
Single proxy, yeah, single proxy.
Okay, so so I just talking about your slides preparation. You talk about this as challenge. So where is the challenge here?
Sorry.
Where is the title of these slides? It's called a challenge. And where is the challenge here?
Oh, I will introduce later.
Okay. So maybe I'll clarify that. Usually, so the first bullet is for the traditional work of a proxy-based approach, as for training the metric training for metric the loss for metric learning. And the second is actually evaluation metrics, and this metrics can either provide the training, testing, or whatever they set, right? So basically, we just introduce the metrics for.
The idea of this paper is I will design the loss based on evaluation metric, but the traditional type of training loss is actually not related to the evaluation metric. So we need to have a new kind of loss.
Maybe there's an indirect relation between the loss and the evaluation metrics.
Yeah.
And I want to mention that the loss itself is nearly the same with t-SNE, the similarity measurements of t-SNE. The difference is that here they use cosine distance, but in t-SNE they use the Euclidean distance.
Yeah, actually, I see some of the work also use Euclid.
Yeah.
I think that's a common approach to
Yeah.
evaluate the
Distance or similarities.
When we want to project the samples from one space to another, and we want to preserve the distance, and this is a common practice.
So now we want to use recall at k as the loss. But the problem is that this recall at k is a non-smooth and non-differentiable function. We can see why. We can do some rewriting for the recall at k. First, we express the numerator as the sum of some indicator function. So let's say this indicator function. We iterate through the samples in a gallery set that has the same label as Q. And then we count how many of them falls into the k nearest neighbor set of Q. So this is just to express the description here mathematically.
Sorry, Ruofan, we'll go back to the previous ones. So the recall at k, maybe I get a little bit confused here. So does the size of PQ always equal to k?
What's the size of?
Maybe I get confused. I get a bit distracted a little bit just now. So this size is a dynamic one, right? Or the fixed one, the size of the
Dynamic one.
The dynamic one. So maybe I get a little bit confused here. Could you go back to the previous slide? So about the definition, I think I missed a point here.
The samples in gallery set that have the same class as Q.
The number of samples have this. So the denominator is supposed to be very large, if I understand correctly.
Yeah, this is actually the upper bound of numerator, right?
So assuming that we have suppose have SIPA 10, a testing set of 10, it have 10K, 10K samples, and each category will have 1K samples. Suppose they are evenly distributed. In this case, the number of samples have the same PQ will be 1K. Am I right?
It's 1K minus 1 because you need to deduct.
Okay.
Mm.
And so, okay. So suppose we have a gallery. It means that suppose the gallery set is fixed. So it seems to me that the size of the PQ will be fixed.
Oh.
If I understand correctly.
Yeah.
But it's supposed to be very large.
Yeah.
And the number of samples. Okay.
I actually find that the definition in this paper is different from previous one.
Yes, I just feel confused. By right, we just have a cycle and just count the number of the.
I actually feel here they are computing precision at K instead of recall. Because in previously, the recall is defined as if there is at least one sample in the K nearest set that has the same class label, then we count as one. Mm.
Okay, so let's go through his definition, whatever.
So this slide is okay, right?
Okay, so it's just a became a counting problem, right? So we just find the K.
Yeah.
Yeah, so I agree with you that it seems to me more like precision instead of recall based on the definition.
Yes.
Right? Because this number is almost fixed. Any student can correct me if I am wrong. I think I'm not in a sharp mind at this moment. But anyway, I just speak out what I saw. So these set is supposed to be a fixed value. So whatever it is, 1K minus 1 or 1K is a fixed value. But for this one, it is just count the number of the corrupted, the number of corrupt. So the number of corrupted or the number of neighbors with correct label, right? Suppose we have K neighbors, and we just count the number of correct neighbors. So this is just the semantics of these equations.
Yes.
Okay. Please go on.
Mm. And the paper further rewrite the indicator function as a step function. So here, there is a R function. The R here is the rank of X, where we are ranking by the similarity to Q. And then this step function will take value of 1. If this K minus rank of X is larger than 0, in other words, the rank of X is less than K, that means X is inside the K nearest neighbor. Is it clear?
The ranking of K similar to Q.
So given
so-
the Q, we just rank all the samples in our gallery set according to the similarity to Q.
Okay.
Yeah, so the rank would be 1, 2, 3, 4, 5, like this.
Okay.
And if the rank is less than K, then we will have a value of 1 and 0 otherwise. So it's just rewrite the indicator function again as a step function.
Okay.
And they further write the rank also in terms of the step function. Because how we get this rank, we get this by comparing the similarity between Q and X and similarity between Q and any sample from the gallery set. So we need to count how many times that my SQX is larger than SQZ. That means the similarity between Q and X is larger.
Okay.
Yeah. Oh, so basically, you can observe there are two layers of step function. And because step function,
What function? Sorry.
step function.
Step. So what is step function?
So the full name is called heavy set function.
Okay, H. That's H means so.
It will
So where is there a definition of step functions?
the definition of step.
Hmm.
So it will only take value of 0
Or,
and
what do you mean is step function?
step function.
Okay, so I'm not sure it's just my problems of my audience, so I cannot see your pronunciation properly.
Step function.
Okay. And Ruofan, I think your voice is a bit noisy. Is my problem starting to feel the same from Ruofan's side?
It seems the mic is not good today. I'm not sure.
I changed the earphone. I lost the old earphone, so I changed it.
Oh,
Maybe can you change another? You just do not use earphone. You just plug it out, just using it.
Is this better?
Yes, it seems better. At
Okay.
least there's no noise here. Okay.
can you explain this formula again? The last line.
The last one.
The last one.
So basically, we are comparing SQX and SQZ. SQX is the similarity between Q and X. SQZ is similarity between Q and any Z from the gallery set. And this Z is not equal to X. So basically, we want to count how many times that my SQX is larger than SQZ. If it's larger, then the rank of X is deducted by 1. Right, because it's more similar to Q than Z.
But by the way, can you go back to the previous one?
Previous one.
Yeah, previous one.
This one.
Wait, my screen is stuck. Okay, so that means the K is okay. So this is ranking. K is a fixed number, right? Okay.
Yeah, K is the K in the KNN.
So X is a sample with the same label of Q. Is that assumption?
Yeah.
But there's no definition here, right?
Here is the definition. So X belongs to PQ. So that means X is from the gallery set and also have the same label as Q.
Okay. The next one.
Next one.
H is okay. So
why there's a K minus 1? Minus 1. Where did that come from?
I think it's because if SQX is larger, then it will get a smaller rank. So there's a negative relationship between the quantity of SQX and the rank of X.
Okay, let's keep going on. Yeah, I think I have no progress on this.
So this each function is actually non-differentiable at 0 and non-smooth at 0. So that's the problem of why we cannot directly use required k as the loss.
So you just need to smooth
Yeah.
the step function.
Yeah.
Make it differentiable.
Make it, yeah.
But the problem is that you have two steps, so it is a nested step function, right?
Yeah. So you need.
And also especially the step in the inner side, it seems that it need to compare inner pairwise. So there's a huge number of comparison there.
Yes, I also have this concern. I think it has the same problem as the pairwise loss because it needs to do the pairwise comparison anyway.
Okay, let's see the solutions.
So
basically it almost design a loss function for ranking, right?
Yeah.
So okay, so basically it design a function for ranking, and also the ranking supposed to. But anyway, according to the algorithmic series, any ranking should be no faster. So the normal ranking should be no faster with a complexity. I will have a complexity of n-log n. So it means that if we want to ranking it, it will definitely be very computational expensive. Especially we have the thousands of train data.
Yeah, so they do it batch by batch. So in each batch they compute this loss. In each batch you only need a similarity matrix.
So it's just an estimation.
Yeah.
Or a batch. Okay, keep going on.
Okay, so the contributions of this paper are two. The first one is they use the differentiable approximation of required k as training loss. And because required k needs to do a pairwise comparison, so they need to have a very large batch size in order to learn the global geometry. So in order to achieve a larger batch size, they use a mix-up technique. This is the original step function. I plot out the outer edge. So the y-axis is the numerator for required k, and the x-axis is the things inside the outer edge function. And at 0, there's a sudden jump, which makes it a non-smooth and non-differentiable function. So they use sigmoid to approximate such a 0-1 function. So it becomes differentiable everywhere and smooth everywhere.
If it is a sigmoid function, when it equal to 0 is supposed to be 0.5, right?
Yeah.
Yeah, so okay, this is a very minor. Yeah, so this is just a very minor issue. My follow-up question is that for sigmoid is not that friendly for differentiation. You can think about it as long as it falls into, suppose it is larger than 3 or 4. I'm not sure the exact number. The gradient will be very, very small.
But that will be 0. Yeah.
Right. So in this case, I don't know which way to go. Maybe we turn into a ReLU like loss function. We could get more smooth or easier for training. I don't know.
But ReLU will be like a straight line then.
Yeah, but
very far away from the original step function.
But anyway, so it means that yeah, I think there's a trade-off between the learning the learning rate and right. But suppose that means my point is that suppose we have some point here and we want to train it to be here, right? So based on this shape, it's very hard for this point to move. The gradients just disappear. I don't know, maybe you can
If
have
you
a try.
have things here,
Yeah.
that means this is very negative.
Yes, but this ground truth label is here to here, right? So it means that once the inertial version is very unlucky for us to get point here, it is very hard for us to train the back, to train and to make the model to learn. So that is just my feeling for the formula.
So I think if it is very negative, because this term is actually the rank of x, if you remember. So
Yes.
this is just k minus the rank of x. So it's very negative means the rank of x is far larger than k.
Yes, but actually it is the label.
Not
But
a
actually,
label.
the point
So
is that
it's
suppose
not
the Q have the same label, right? So, but this one, I mean that there is a point. The point is there's a manifold
very
here.
far. If it's
Yeah.
very far, then we do not care about this point.
Why do we
If
not
this
care?
rank,
So
this is
the rank
actually
is
just the k minus the rank of x. So if it is less than some negative number, then that means Rx is larger than k plus delta, where delta is very large. So this point is very far from Q, and we do not care about pulling it closer. But if this Rx is close to K, in this graph it should be something like here. Then we care about this portion maybe.
in this case, I mean the algorithms will not work if all its neighbors are false. Am I right? Suppose we have a batch and all its neighbors are of different labels. And then if the one is far away and this function will not work anymore. So I just raised a couple examples for when the formula does not work. Do you think that makes sense?
It means that all the samples are not in the KN set.
Yes. And the correct one is just a little far away. In this case, the loss function will not work because there's almost no gradients to pull the function back to the sample back.
There's no gradient.
But anyway, but when we train the model, I don't know if we can introduce some stochastic factors to reshape it, but I don't know how.
Actually, this part is okay, right? But this part may have some problem.
Yeah.
Because this part is when the rank is less than K.
Yeah. But sometimes some cases it happens here. So I just raise some cases where these functions may not work well because anyway, they're just smooth. I understand there's a trade-off. So because these step functions looks more similar, this sigmoid looks much similar to step function. But if we change into a real loop somehow there, but anyway, we need to simplify something. So maybe a mild approach is that we introduce a temperature. Right. Right. If we
introduce a temperature.
Yeah, we introduce temperature, so it becomes much more like relative. Do they have a temperature?
Yeah, they have the temperature.
Oh yeah. So that
but
makes
the
sense.
temperature is one temperature is 1, the other one is 0.01. So yeah.
That makes sense because this one, that makes sense because this one requires a lower temperature to make it smoother.
A lower temperature will make it
steeper.
Yeah.
Oh yeah, you're right.
So you can see if tau is equal to 1, then this is the normal sigmoid function we have learned. But now we have additional hyperparameter tau here. So the temperature in sigmoid is similar to the temperature in softmax because actually there's a connection between softmax and sigmoid. Sigmoid is just a binary class case for softmax. For example, if softmax only have 2 classes.
Oh, by the way, when the temperature becomes, so 0.01 means the temperature T tau here equal to 100, right? If you multiply 0.01, it means the tau is 100. So if it is 100, it means that it becomes smoother.
If you look at the class distribution, it becomes smoother. But if you look at the function, if you look at the function itself, it is deeper.
So can you elaborate a bit more about the tau here? So when the tau becomes large, and there's less distinguishment between the options, right?
Yeah. So when tau becomes large, then it's more reluctant to have a sudden jump to 1.
So this is a U. U is
U is just the x-axis. And we are plotting sigmoid over U with tau equal to 1. And the right-hand side is tau equal to 0.01.
I feel the weird. Xiaoning is Xiaoning there.
Oh,
So what do you feel when the temperature becomes larger? And what is the trend? I just feel, is that my problem? So when the temperature get larger, it gets steeper. Is that correct?
when the temperature becomes large, because you are using 1 over tau.
Yeah, we are using 1 over tau, right? So suppose it's mu, right? The mu, if we divide it by 100, means that if we make a step, suppose we make step 1, it will raise this value. Now we need to raise 100 to raise that value. So I just feel that why it gets steeper. My fear is that it gets, the tau is 0. You want divided by 0.
Oh yeah.
Okay. The point is, can you go back to the previous slides if I remember correctly? Can you go back to the previous slide? The slide here is that the previous one. You multiply by where is the temperature you use?
Here, divided by temperature.
Okay, so you divide by temperature. So their choice is that when the inner ones you want is steeper, get steeper. Okay.
Yeah.
Okay, I misread it. Sorry, I misread the formula here. So
But why for the inner part they wanted to be more steeper?
I think they want the similarity comparison to be very sensitive. So if XQX exceeds XQZ by a little bit, then this sigmoid function will soon becomes 1. So yeah, I think it's to make the comparison.
Really? So if it's steeper, it becomes less sensitive, right?
It's steeper, then it will have a sudden jump to 1, right?
It means as long as they are getting closer, it will jump to 1. But if there's a large difference, if there's a large difference like this,
I mean, if their difference is close to 0, if it's close to 0, then if you look at this graph, then maybe it's have a less than 1. But if you look at this graph, then it becomes
The point is that suppose there's if we want to train a network, and if the incorrect ranking fall in this area, why does not allow training, updating? So if the difference fall into this region, and the model the weights will not update anymore, in a wider case?
I think they just ignore it when the similarity difference is so large.
I don't know, maybe that is an empirical, maybe these achieve the best result. But I just seem to
You see,
compute-
because they are using it as a loss function, so each time they only drag those because for KN you are drawing a circle, like drawing a circle, and then they just drag those points that near that circle inside.
Yeah.
And then each time they update the network, so they can going from a circle that with smaller radius, and then I'm not sure.
I don't know why they favor. So basically, apparently they favor the misprediction just near the circle, right? So
Yeah.
based on this formula, suppose there's mispredictions a little bit far from the circle, they just ignore it, right?
Yes.
So it means that we have a lot of chance. So the point is that suppose we have a Q here, right? Suppose we have predict. So suppose we have a circle here, and if there are several predictions very closer to the Q, but they are misprediction, and they were not updated. So there's no way to kick those points out, right? Only those points, maybe here, those points can be adjusted. But for those points, especially for those points, they will not be adjusted. There's no way to pull these samples out.
Yes, but I think when we do evaluation, we just look at its neighbors. So I think during training, it's okay to just look at the local region.
Yeah, I'm just talking about the local region. That means we want
because during testing, we are also looking at the neighbors. So it's okay that during training we only care about
do you mean what this part? So this part means that if several neighbors, series close neighbors, the most close neighbors is a misprediction. That means if the Q is a cat and the close neighbors are all dog. And maybe the close neighbors, maybe the when the ranking is 1, it's rank 1 and rank 2 neighbors are all dogs. It's almost.
But if you put the correct neighbors to be closer, then these wrong neighbors will be corrected, right?
But it just so based on this formula, so we just pull the circle back to the limit, right? So that means this one will be there, right?
Yeah.
So there's no way to kick them out. So that is my concern. If we using the steps, the step functions, there's no way to kick them out.
In the paper, they use multiple key values. Then if we use multiple key, then is it a solution to this?
Multiple key. So during the training.
K equal to 1, then if you say K equal to 1, then
you can kick them out, right?
You can kick them out.
Okay, so maybe I raised questions too early. But anyway, so when they're using, I just have a concern for the sigmoid function because it's usually the ringleader for gradient disappearing effect. Okay, let's keep going on.
Yes, so this is the approximative recall at K. We want to maximize this. So in our loss, we use 1 minus the recall. And we incorporate different K values. The K is the K in the KN. And just average over different K.
So if we introduce K values, it means that it is further increase the computational effort.
You only need to compute this similarity matrix, then that's all, because it can be used for any K.
Okay, yes, you're right. You're right. You just need to compute the pairwise distance, right?
Yeah.
Okay, so that is okay. So in this case, it can solve the problem to kick out the close the misprediction.
Hmm.
Okay.
The part 2 of approach is they use the mix-up strategy in training. So for training batch B, they use mix-up in embedding space only between the same class pairs to generate a set of virtual samples B prime. Sorry, B prime should be a batch of samples instead of one sample. And then the batch size is increased to be B union B prime. However, they argue that we don't need to cache the B prime. We actually only need to record the alpha x1 and x2. Alpha here is the mix-up coefficient, which is drawn from a random uniform distribution. X1, X2 are two samples in your batch.
Oh, by the way, so what is the purpose of mix-up for generalization?
They want to increase the batch size.
Increase the batch size. Okay, so keep going on.
And because in our loss, we only need to compute the similarity. So the similarity between Q and these virtual samples is defined as this and can be expanded to be alpha SQX1 plus 1 minus alpha SQX2. So the virtual sample similarity can be computed directly by using the real sample similarity. You don't need to compute SQV again. You just need to know alpha and which X1, X2 you are using.
So what's the
Also, if you cache the B prime, and then you need to do the inner product again when you compute the similarity. But actually, it can be expressed as the linear combination of the old similarity. For your
this is just this it seems to me it's more just like it's more like a data augmentation.
yes.
Okay. So by these ways we can choose even different alpha to further generalize it.
Yeah, which doesn't incur additional computational cost, so it's efficient.
Okay, but I still need to calculate. I think it is a trick to have more samples in a batch, but it will still introduce some computational cost when calculating objective function.
Because anyway you have to compute these things, so you only need to do a linear addition and multiplication, and that's all.
Yeah, it introduces linear complexity.
Yeah.
Yeah, basically, so suppose given the batch, if we want to increase the batch by 5 times, and each time we calculate it, the complexity goes into 5 times. So it introduces the complexity incurred is actually linear.
Yeah. So one thing I noticed, the different from previous work, because in previous work, we use mix-up between different classes, but here they only use mix-up within the same class. So I think they do mix
Within the
up
same batch?
within the same class, not
Okay.
between different class. So I think it's more like increasing the data batch instead of generating some unseen classes.
I think it does not make sense because this mix-up can calculate on the fly, right? So from my point of view, it can be the mix-up either inter-class mix-up or the inter-class mix-up. It doesn't matter.
Yeah.
But can you go back to the previous slide? So when we select the previous slide, so when we calculate the mix-up, So in a batch, the x1, x2 can be either fall into the same category or fall into different category.
Well, in this paper, they only use same category mix-up.
Why?
I
Because
don't-
but we can do, technically we just can do whatever x1, x2, right? Maybe
Yeah, we can do different class as well, like other works. Yeah.
so. Can you raise this voltage if we mix up the images from different class? So the author believes that if we mix the images from different class, it will cause some invisible images, or the images does not fall on the metaphor.
Maybe that's the reason, but they didn't mention in the paper why they do not consider.
Okay. Okay, you can keep going on.
Maybe one reason is that a problem of using mix-up is after you mix up, you need to assign a class label for it. But when you are calculating the loss,
You're right. Yeah, you're right.
need to use the original label. You don't want to use any synthetic label.
Yeah, you're right. So the cat plus the cat is still a cat, but a cat plus a dog, we don't know what it is, right?
Yeah. But in the previous work I present, they actually do the interclass mix-up because they do want to generate some unseen class, but here maybe they do not want to use this trick. So they just do it for same class pairs.
Okay.
For the experiment section, I'm thinking maybe we can use some of the data sets they use in the paper because some of them I didn't see it in previous papers.
So I think this idea seems interesting, but basically it change a loss function, incurs additional runtime cost. But anyway, their changing seems a little bit interesting. But if I were the reviewers, I would like also to provide a more proof or property analysis for this loss function. So maybe that is what I expected. For example, just so we discuss, and how do we kick out the close to misprediction? Or maybe maybe also we provide analysis whether we need to pull the mispredictions really far away. That means, then the first is that how do we kick out the false positive, and how do we pull back the false negative, or whether there's a necessity to pull back the false negative really far away. So it's better they can provide such analysis. So I will enjoy reading the paper more. Otherwise, we just based on discussion and analyzing the properties by ourselves, and it just tell us how we do it. But it provides less justification. Even if the result is good, I will still have my own concern.
Actually, I think the idea is interesting, but the result is not that
impressive
because you can see this is the proxy NCA++ I'm using. So you can see its result is very good, right? And then if we just use the recall at K loss, the performance is not better than proxy NCA++. But after we use the mix-up trick, then it gets better. So the loss itself is not very efficient, but the trick may matters. And also if we increase the batch size, then it gets better. But you know that in proxy NCA++, the batch size is only 32, but here they need to use such a large batch size in order to get a better result than this. So
Yes, you're right. And also another counter argument is that we can also apply the centric. And what if the proxy NC++ plus the CMix, right? And it is still possible. So if we equipped the CMix technique or trick, we equipped the proxy NCA++ with the technique of the CMix, maybe the result can get even better. And the benefits is more introduced by the data augmentation instead of the loss function design.
Yeah.
I feel that it's very computational expensive. And yeah, I don't know. Let's have a look at it. And also, I feel that the proxy loss is somehow, it is not explicitly defined recall matrix, the recall evaluation, but the loss function introduced by proxy NCA++ is actually indirectly related to the recall. So I don't know if it is possible that we can find a proof to prove that these two laws are equivalent or actually targeting with the same semantics or embedding almost the same information. So if that's the case, we do not bother to train to introduce more effort, right?
Yeah, I think there are some relationship between the loss used in proxy base and also the recall IK metric.
Okay, maybe we can serve this as a baseline. So what do you think?
Oh, the code is not released. Because it's still on archive, so I don't know when it will be published. This paper is put on archive in August this year, so it's very new.
So more likely it is a submission for TrueAI this year.
Oh, maybe.
Okay, well, let's keep going on.
So they do have some ablation study, like this is what I mentioned. They try different K values. So they try K equal to 1 and K equal to 1 and 2. So they will find that using K equal to 1 and 2 is very important. And
out to the false positive. Maybe that's really to pick out the false positive.
Yeah. So, but if you include more and more K, then it does not bring additional benefits.
But it does improve the K equals the measurement of R at age, right? Oh, it does not. It does not.
Because by right, if the recall at 1 is higher, then all the following recall should be higher, because recall at 1 is a more stricter requirement.
Okay, but anyway, I feel that it's an interesting idea to learn.
Yeah. So this is the true choice of tau we have discussed. The takeaway from this paper is what you evaluate, how you train. So we can design the training loss according to the evaluation metric. That's all for the presentation.
Yeah, so maybe I have a few questions for the audience. I'm not sure how much of the audience will still follow the work. So I think the most invaluable part of this paper is smoothness. Just for me, if we do not look into the result, I think what attracts me most is about the step function smoothness, right? So but I think it does not impress me a lot by the mixed up technique, because it is just a way of the data augmentation. I'm not sure whether you share the same value of me. So in terms of the property, the search loss property, and is there anyone would like to express your opinions on this technique? Xiangling, would you have tried to make a comment here? What if you are a reviewer? And also, this is a very open question because this is highly likely a triple AI simulation, and authors may or may not receive the early, may or may not pass the first round. So if you are the reviewer, what's your point on there? So if you were the reviewer,
yeah.
what kind of score you would give the authors?
Not sure, borderline, because the experiment result, it didn't improve much than proxy NCA, right?
Apparently you are influenced by my comments. So what if you haven't learned my comments, and what score will you give it?
Somewhere between borderline or weak.
Weak what?
Weak. Weak. I'm not sure. Borderline.
And Dr. Xiaoyan, are you there? Hello.
Yeah.
If you were the reviewer, and what score will you give him?
Maybe I will give weak reject. Yeah.
A weak reject. So
Just as you, I agree with you that there are two parts, and the second part mix up. Also, indeed, it didn't give me much. I mean, great impression. And the first one, yeah, I agree with the paper, but the question is, it didn't provide much improvement. Then it will make my judgment lower. Yeah. But
so the point, please.
I think it's still up to the writing. If the writing, whether it can, make me
interesting there.
Yeah, increase my score, it also have some influence. Yeah.
Okay. So I just if I'm the reviewer. Before I do this, I still ask some AI students and Mengyue and Yufan, what's your opinions on this paper?
Actually, I'm agree with you, Professor Lee. Yeah, I think the SIG model he used is quite how to say, novel, but the computation cost is maybe very large. But he proposed an interesting solution, I think. So I think it has its meanings. Yeah.
Yeah. And Yufan, what's your point?
I think they need more experiment. The current result seems not quite good. So I think need more, get a better result.
Yeah, so I think all of us are quite picky reviewers. Didn't give the author a chance, either borderline or we reject. So anyway, so I just feel that it does make a point, and incorporate some novelties, and I do learn something from the paper. So summarizing all of the students' comments, I think for this paper, the first is that I think Ruofan has faithfully present what the paper has, and even made his own animation and graph to interpret what he understands. So that is a very perfect presentation. And based on the presentation, I'm not saying Ruofan's understanding, I'm saying the authors. So I just feel that we need a more thorough analysis for this normal loss function. So just you mentioned, so we have a step function, we make the differentiable, but it incur computational cost. And what is pros and cons, right? So compare to the traditional approach and what additional computational cost we incur. So that's a part we need to analyze from an experimental point of view. And also, if there's a theoretical part, we may even calculate the complexity from the approach, right? So if we want to make differentiable, and what is computational complexity, especially comparing to the state-of-the-art proxy NCA plus approach. And the second is that I just feel a little bit weird is that it equipped the C mix technique with some other baselines, but not for the proxy NCA and the hold or normal softmax, right? And all these approaches are actually have better performance when RS is not equipped with the CMix. So I'm not sure whether they have some analysis or argument for that. So the first reason is that if they want to equip the CMix technique, they are supposed to equip such a technique with all of them. Or if I would pause author based on the result, I might be rephrasing the paper and augment that claim the contribution for such a runtime delimitation, right? So in this case, we can rewriting the paper saying that maybe this paper have two contribution, and the runtime augmentation, the runtime delimitation, or the computationally efficient delimitation would be another contribution, and also the loss function. And the loss function had a novelty, and the runtime delimitation and have some practical meanings. So maybe I don't know how to improve the papers, but anyway, it depends on how they're going to sell the ideas. Okay, so I think we have enough discussion for this work. Next one, how about Yufan? Hello, Yufan.
Could you see my screen?
Yes.
Okay. So today I will present a syntax guide edit decoder for neural program repair. It was published on FSC 21. And from the title, you can see that its main contribution is that innovation, or you can say innovation is that it rebuilds the decoder. The decoder is a part of the encoder-decoder architecture. So he built a new decoder for the neural program repair. There are 7 others. The first 2 is a PhD at Peking University, and they are all researching on soft testing, code generation, code representation. And for the following 3 others, I can't search their information. Maybe they are undergraduate or master student in Peking University and Stony Brook University in United States. And the last 2 is professor. The last 2 are 2 professors, and the first is Xiong Yingfei, and he is assistant professor at Peking University, and he mostly focused on program repair and synthesis. And another professor is Zhang Lu, is a professor at Peking University, and he mainly focused on software maintenance and evolution, software analysis and testing. There are 2 professors, they are supervisors of the first 2 others.
By the way, my comments for the last 2 professors, and they are supposed to 2 of the most prolific or productive professors in Peking University. You know that in terms of software area, according to CS ranking, Peking University ranks first in the world. So maybe in these 2 days, CMU surpassed Peking University in terms of application. But in the group of the Peking University, and those two professors are two of the most productive ones.
Okay, got it. And they are the supervisor of these two PhDs. And today we will have 6 sections. And the first, I will introduce the program repair, and then I will analyze the limitation and the motivation of current model, and then I will introduce the new model, and then I will introduce the data set and the experiment result, and finally the conclusion. And first, what is the APR? APR means the automated program repair, which aims to reduce bug fixing effort by regenerating patches to aid the developers. And the input of the API is the faulty statement and its context, and the output will be the right statement. And the current work is just generate a new statement to replace the faulty statement located by the fault localization approach. So you need first got a faulty localization approach to tell the API what is the wrong statement, and then the API will generate a new statement. And the existing deep learning based approach are based on the encoder-decoder architecture. The encoder encodes the faulty statement as well as any necessary code context into a fixed length internal representation, and the decoder generates a new statement from it. However, there are some limitations. There are proposed different encoder architecture. Actually, we have introduced many different encoder architectures in the previous, paper presentation. So here is the question: anyone can introduce some different encoders.
You mean that raise some examples of the encoder?
Yeah.
Okay, so maybe you can suggest any audience here?
Yeah, maybe Ruofan.
Oh, hello. Sorry. What's the question?
The question is that could you introduce some encoders you met during your research?
Variational encoder.
Yeah, first variational encoder, and any more?
Normal encoder.
Okay, so for example, last time I introduced the AS tree. So if we want to encode the AS tree, we needed to reorganize the encoder. Do you remember what I used for the encoder?
Yeah, anyone remember Yufan's last presentation? Dr. Xiaoyan, do you want to mention something?
That's the convolutional encoder.
Convolutional encoder. Yeah, I also mentioned convolutional encoder. Any other encoder? Actually, last time I mentioned the capsule network. Anyone remember the capsule network? It encoded the ST tree. And I also mentioned the tree LSTM. Tree LSTM. Anyone have some memory? And we also mentioned the GNN also can be used to the encoder of the AST tree. Okay, so however, during these different encode architectures, the current decoder remains to be the standard one, which generates a sequence of tokens one by one to replace, the statement. And so this paper thought this decoder has multiple limitations. The first, it only allows to generate syntactically incorrect programs. And secondly, it is inefficiently representing small edits. And the third is not being able to generate project-specific identifiers. I think the first one is easy to understand. I will explain more on the second and the third point. Any question here? Okay, So for here is the example. You can look at the figure 1. This patch only changes one token in the statement, but under the current, framework, it needed to encode as a sequence of length of 13, and the program space contains this patch would roughly contain many elements. But on the other hand, if we just consider a patch space include only one token changes edits, and to generate only select a token in the 40 statement and a new token for replacement. So this generate space would be much smaller. And for this example, you can see that here is a different variable name. So it is hard to generate because this variable name is defined by the software engineer. So the existing deep learning-based API approach only generates identifiers that have frequently appeared in the training set. However, different projects have different sets of project-specific identifiers, or you can say the variable name. And therefore, only considering the variable names in the training set may exclude some possible patches from the space. So to generate this patch, this paper used to some identifier to generate the available local set, this identifier name. Okay, and then I will introduce how they solve these problems. The first is a new architecture for the decoding. We use a provider and a decider architecture. Overall, the decoder components of this model called the recoder, and we don't use this name because it's quite confusing. You just say the decoder. The decoder produces a sequence of edits rather than a new statement. And for an unexpanded non-terminal node in a partial S tree, the decoder estimates the probability of each grammar rule to be used to expand the node. So currently, the decoder not generates a statement. They not generate a statement, but generates based on the rule. So he just generates the rule to expand the node. So what is the rule? Here is some rules. It defines 6 rules. As defined by the rule 1 and the rule 2, an edit is a sequence of edit ended by a special symbol and. The special symbol and an edit can be one of 2 edit operations: insertion and modify, insert and modify. And the rule 3 defines the syntax of insert operation. The inserts a newly generated statement before the 40 statement. It has only one parameter, which is the statement or to insert, the HLS statement. HL stands for the host language. So it just inserts a statement based on the host language. And the HL statement refers to the non-terminal in the grammar of the host language that represents a statement. This non-terminal could be expanded into a full statement, or just a copy operation that copies a statement from the original program, and it will be used here. So it's just a copy statement of the context, and I will introduce later. And
so here, does these rules including deletion?
Deletion. I think the modify also includes the deletion. The rule 4.
Rule 4. The rule 4 and the only will identify the ID and the. And by the way, what is NTS?
NTS is here.
Oh, non-terminal. Okay.
Non-terminal. Non-terminal symbol. So rule 4 defines the syntax of modify operation. The modify means replace an AST subtree in the faulty statement with a new AST subtree. So maybe it can delete something. The modify operation has two parameters. The first parameter is the ID of the root node from the AST subtree to be replaced. And the ID of a node is defined as the order of a node in the pre-order traversal sequence. Pre-order travels the AST tree. And the second parameter is the ST subtree whose root node has the same symbol. So in this way, the replacement ensures the syntactical correctness. Any question for the these four rules? Okay.
So wait a minute. So here is a rule. So this is usually called the production rules. So production rules usually describe the syntax of a set of expression, whatever it is. So here we have the rules here. So Yufan, can you raise the example? And so we can raise a few patch, right? Do you prepare examples for these rules? Okay, then that is fine. So now I think you can combine the examples. So I do not need to raise examples for the rules.
Yeah,
so you can
first introduce the later. I think these are more important rules because it's a bit complex. Yeah. So for these two rules, you can see that first copy operation is introduced to further reduce the patch space. Mostly you just copy another, copy the code from the context. You just need to copy the context code. And the Ruofan defines the syntax of this operation. And it is a meta rule applied to any non-terminal symbol of the host language. For any non-terminal symbol in the host language, they just add a production rule that expands it into a copy operation. Any question on the copy rule? Okay. And the rule 6 introduced a placeholder in the grammar. So I just mentioned because there's many, different.
Sorry, I read questions here.
Okay.
So given a non-terminal statement here, so suppose we find an ID or find an AST within the. So, and can you raise an example of the copy? So the copy means that we fully replace it, or we insert additional.
We just look at this example. This example inserts an if statement, and the conditional expression contains a method invocation that is copied from the faculty statement. Maybe we can get that. First is the edits rules. It's the first rule, remember? And this is the second rule, edit. And then this is the third rule, modify. And then modify, as mentioned, they can have first is another ID. This ID is copied from the here. This is copied from here, and here is the qualify. Maybe we go back to the rules. This is modify.
I think once you have a tree, we do not need the rule, right? So once we have the tree, we can just elaborate the rules based on the tree. I think that'll be enough, right? So basically, the left tree is the code version before repair, and the right tree is basically a set of operation. It's going to apply it on the left tree, so that the left tree will generate another version. Once the operations are applied, or when the right tree has been applied on the left tree, and we finish the repair process. And then maybe if I can start with the node ID and qualifier to specify the actions.
In this example, this variable name is wrong. This is a wrong statement. So now we need to generate a sequence of edits. Then it generates the this tree here, and when you need to modify something, he just first look at the original tree. Original is the method invocation here. So after he copies this method invocation to here, he finds that there is a wrong in the the qualify, because this is a wrong qualify. So he needed to find a new qualify, new, or you can say the method invocation here. And because the row 6, it only put a placeholder, because the method invocation is defined by the software engineer. It's not defined by the host language. So he just put a placeholder, depends on the row 6. And then after the whole process, he will replace the placeholder with the most suitable name. And I go back to the rows. For the row 6, it is the placeholder, and it will be replaced by the identifiers in the training set. So
the training set. So it's supposed to be a project, right? So why it is identified?
No.
Oh, it's either or. Sorry, it's either a replacement.
If this possibility is very high, then it can be identified in the training set. If not, it will put a placeholder.
So the question is that when we generate the right tree, we generate the tree node by node or in one shot.
We generate node by node.
Okay.
Yeah.
So that means the synthesize. Okay, so basically just based on the context, we just so another question is that when they are generating the right tree and let's call it a modification tree. So I just call it a modification tree. So when we generate a modification tree, each time we make a prediction, is a model provide a deterministic or non-deterministic tree, or deterministic or non-deterministic result?
Pardon, please.
The point is that so given such a statement, the first line return C available before set, etc. So when we generate the operations on these statements, each time we apply the model, is the model prediction deterministic or non-deterministic?
What is the last word?
Whether, let me rephrase. So whether the outcome of the prediction is deterministic.
Deterministic. What is the meaning of
being deterministic means that each time we make prediction, the result will always be a fixed result.
No. It will has a beam search to find the most possible, most possible sequence, most possible tree.
So it is a deterministic result, right? If using beam search, so each time we make the prediction, we always have the same predicted operation.
Maybe it's not modified. Maybe it's the insert.
It is a beam search, but by the way, it is a beam search, right?
Yeah.
It's a beam search. Beam search is supposed to be fixed. Supposed to be a fixed one.
No, it will have many possible. It will have a search space. And
yes, yeah, it has a search space, but in the search space, it will pick up the sequence with largest probability. So when we have being search, the result is supposed to be deterministic. And the showing there. Is being search algorithm the deterministic algorithm or non-deterministic algorithm?
Actually, I'm not sure because I never.
Huh? You give I
give the presentation, but
I think
because I don't know how to calculate the probability inside being
the probability is given by the model.
So it's deterministic.
I feel it's deterministic.
Then it's deterministic, right? Because there is nothing.
But this model, I think it predicts a possibility every step. So
if I understand correctly, given the beam search, this beam search is not a full sequence. It will generate multiple tree, right?
Yeah.
based on being searched. And we just need to pick up the tree with largest probability. And that's all,
Yeah. Yes.
right? So it is deterministic.
Yeah. If that is-
Okay. Let's keep going on.
So, so these are all the 6 rules. And then another novelty I just mentioned is a placeholder generation. So you can just have a much smaller space to generate identifiers. And here is the provider decider architecture. The provider is a neural component that provides a set of choice for expanding a non-terminal and estimates the probability of each choice. There are 3 types of provider. I can say the paper only defines 3 types of provider. The first is raw predictor, and it is as the following point. They can predict several choice. The several choice, maybe P1 is the edits, and the P2 maybe is the edit, and the P3 maybe the insert. And another provider is the subtree locator, and it only predicts the modifiers. And another provider is tree copy, and it will copy. It will find context to copy. So these are 3 types of providers.
Wait a minute. So what is the last one? The last one
Is the copy.
tree
Just
copier.
copy another tree in the.
By the way, so can you re-emphasize what is HL short for?
HL means host language. If you write it in Python, it's Python. If written
okay. So is there implementations on Java or Python?
I think it can be used in all language.
I mean their implementation.
I don't check the implementation. I think they publish the code. Maybe I can check the code.
Yeah. Okay.
Okay. So these are the providers. And the decider is a component that estimates the probability of using each provider. So for the provider 1, it will get a probability. And so for provider 2, it will get a probability for provider 2. So it will generate 3 probability. And then they just multiply to probability and get the final probability. That's the provider decide architecture. So it's not a very
yes, that's just fairly straightforward. Let's keep going on. Yeah.
Okay. So these are the examples we just mentioned. These are another example for the insert operation. And actually it's quite similar. It first generate edits, and then the provider generate edit, and the decider decide which edit edit or end. And the first is edit, and the edit provider gets the insert, and the decider decide is insert or modify, and then it is insert, then it will goes for over.
Okay, so here I would like to raise a question for audience. So I think Yufan make a very clear explanation about what is input and output. But here I would like to an audience or student to raise some questions based on the slide. So if you want to raise some questions based on slides or up until now, what kind of questions you may ask here? Maybe try. Xianghui, are you still follow the slides or presentation? Hello, Xianghui.
Hello, Dr. Lee. Yeah, I went to the toilet just now. Then after I come back, I'm a bit lost.
Oh, okay. So Yufan, are you still following?
Yeah, I'm following.
So if I force you to raise a question for these slides, and what question will you ask here?
Actually, can I look at the production rules again? I don't know. I would like to ask if this rule is like non-ambiguous, and secondly, I'm not really sure about what the providers are doing yet. So
Also, the question is basically ask Yufan to re-explain what is provider, right?
yeah.
Okay. So Yufan, maybe you can re-explain what is provider.
Provider, look at this picture. Actually, there are 3 types of provider. And the first is raw predictor, second is subtree locator, and the third is tree copper. And they will provide different choice. Okay, different choice. So in the first raw predictor, the first choice may be edit, the second choice may be edit, the third choice may be insert. Okay, any question?
Maybe I can help the explanation here. So Yuchen, if you follow, you will know that the approach aims to generate a piece of code or generate repair operation. And the repair operation, the generated code or the generated repairing code need to be syntactically complete or fully follow the AST rules. For example, we're fixing Java programs, and the code generated should not be at least supposed to be syntactically correct, right? So one of the novelty of this approach lies in that it's not going to generate code, because based on current technique, the code generation is not that reliable. So their approach, the novelty lies in that they are generating the operations on the original code. So this is one novelty lies here. So as long as operation, whatever operation we applied, as long as the rules are conform to the Java syntax, we always synthesize or generate a piece of Java code. So we do not discuss whether this piece of code is correct or not. But anyway, we can definitely generate a piece of Java code which is syntactically correct, right? So here, when we go into provider, it means that, but anyway, a set of operation is still a tree. So you can think about it because it needs to incorporate an AST node. And AST node is a tree. So a set of operations can also be a tree. So in this case, so here, I think the idea of this provider is that first it will decide what kind of the global editor, what kind of a journal operator we have. For example, we want to edit some things, modify some things, or insert something. So this is a rule predictor. So it means that which rule we're going to apply. And once we decide the rule, and this rule have a lot of variants, so then we want to use subtree, or when we want to see, suppose we're given a piece of code, we want to edit it. Then we want to see which editors want to apply. For example, we want to edit the code directly, or we want to copy and paste from some code from the context to replace existing code, or we want to using code synthesize to generate an if block. So that is the basic idea. So the approach, the rule generation is step by step. We first generate a general rule, and then we generate how to apply the general rule. And when we go to the subtree, we will further refine what kind of subtree, sub code we want to generate it. We synthesize a new piece of code, or we just copy and paste from somewhere else. So this is a basic idea of the approach.
Yeah, okay, I get it. I realize where I have a misconception. Yeah.
Okay, so okay, the next maybe I hear the next question I want to say is that if I'm here, I would like to raise a question is that how to encode the tree. So basically it's a transformation or translation problem, right? We translate the left tree into the right tree. We translate the code into the operation. So the idea is that how do we embedding the code here? So that is where my curiosity lies.
It uses the tree LSTM.
The tree LSTM. Okay, let's keep going on.
Wait for a moment. I think he used the many. Because the model is quite complex, I will introduce in later. Because he also used the LSTM, tree LSTM, also use the transformer, and it is complex. So I will introduce later.
I think the software engineering expert cannot distinguish how good the model, whether the model can be used correctly. Let's keep going on.
Okay, and here we will introduce the three, the three components, the three provider, because it is a bit important. However, in this part, this paper is quite, poor organizing and poor writing. So I have to copy here, and you can read this there, because, for example, here he said is the neural component of this decider, but actually this is not decider, it's the provider. So I think it is wrong writing here, but it's have many, some wrong writing in this paper.
So your version is a public preprint version, or already a published version?
Yeah, already published version.
A published version, okay.
Yeah,
see.
Okay. Confusing. Yeah. Maybe I didn't understand correctly.
So here I suggest that we can quickly skip the model design. I think the model design, as a software expert, and they may use the state-of-the model design there. I think it is not a.
They just a fully connect layer and very typical, normalized way. So I think no need to take very.
Yeah. I think we can skip those technical details. It doesn't matter if we want to develop our own. And I think most of the students here may not care about the rule details. We can skip those things. So if you find something interesting, you can just introduce here. If there
no interest in the provided the decider. And here is the whole model architecture. You can see it's very complex and a big model. And we need to look at part by part. Let's skip to here. First is the code reader, and first is the code reader. The code reader, it is the S tree. So the ST tree, first we have a pre-order travels. The ST travel sequence is the tokens following the pre-order travel. So pre-order travels, and then it will become a sequence. And then he used the word embedding. And the second is the tag embedding. Tag embedding is the sequence of tags following the same pre-order traversal, but this tag denotes the following cases. The following cases. The first case is in the 40 statement. The second case is in the statement before the 40 statement, and the third is in the statement after the 40 statement. And the third case is in other statement, or you can say in the context. So the tag is 4 classes. It depends on whether it is in the 40 statement. And then this is AST-based graph. So this, because the other thought, considering the formal 2 inputs do not capture the neighbor relations between the AST tree nodes. So in order to capture the neighbor information, they treat the AST as a directional graph. At least in the left picture, this is a direction graph. And then he puts this direction graph in the use the tree LSTM in this.
Anyway, so they put into all the information there.
Yes.
So here, given tree, there's no specific relation about the sibling, right? So it put in all the information there.
Yeah, but
and then also giving the so here in your example, the input is a 40 statement, right? So here in this graph, it seems the input is a 40 method. So do they need to predict?
The method means this is a whole statement, and the 40 means this method is the 40. But actually, that only one statement is wrong.
But how do we know that? So in this approach, they have already assumed the 40, which statement is 40 statement. They have such assumption, right?
Yeah, I have mentioned before, they have a localization, 40 localization tools. They first use these tools to localize the 40. You know, this tool will tell you which statement is 40.
Okay, let's keep going.
Yeah. Okay. So to ask the before question, here self-attention is the transformer, and the gating layer actually is the LSTM because LSTM uses the gating, and this tree convolutional layer actually is the GNN. So it actually uses multiple models, and it's quite complex here. But it's only for code reader, and then it's for AST reader. And this AST is not the code AST. This AST encodes the partial generated AST. So it is the edit. Remember the tree of the edits. It's just encodes the edits, and the structure is quite the same, but it has the the raw encoding, raw sequence, and the graph. And the raw sequence is just the pre-order sequence of the tree, and the raw encoding is just some text to specify which row it is. And then the graph is just I mentioned he just changes transforms the tree to the graph, and the same architecture here. First is the transformer, then is the gating, and then is the attention because it want to integrate the information before, and then it is the GN. Any question here?
Did the author explain why they use such layers?
No, actually, but he said he is copy from a structure called tree, to another paper called tree generator.
Okay.
Yeah, he just used another paper's architecture, from my understanding.
Yeah, keep going. So I think we should not discuss this part in this group meetings. Yeah, let's go through so basically there's an encoder anyway. It's just an encoder, but the decoder is a little bit different. So maybe we discuss more about the decoder part.
Yeah. So this encoder part is I think is mostly copy or same as the another paper, and this decoder is the innovation of this paper. It have a new decoder. So the code reader encodes the 40 statement and its context. The ST reader encodes the partial ST of the edits that have been generated, and the tree path reader that encodes the path from the root node to a non-terminal node, which should be expanded. And the edge decoder that takes the encoded information from the previous three components and produce a probability of each choice for expanding the non-terminal node. So for every step, it goes, it goes through one times, and then it will be updated. These two will be updated because
but the true path is the operator path or the coder path.
The tree path. Do you mean the tree path?
Yeah, the tree path. Yeah.
The tree path is the code needed to expand it. This is for edits, and the tree path means which code you need to add.
You mean the edit? Okay, so the first is edits, and the second is edit the code, right?
Yeah. This is the new code. So every time it will go through this module and update the input.
Okay, let's keep it going on.
Okay, and here is the data set, and the training data set is crawled the Java projects from the GitHub and use the commit message, and the evaluate is I think is some standard data set is this.
It is a standard.
Yes, that's for standard data set, I think.
Here's a problem. So, but I think you cannot answer this question, but I just raised it here. So this for such a 1 million commits, the big problem here is that the data is noisy. So think about it, if we get only one commits, okay, so it filter out 90% of the patch, right?
Yeah, I think he has a filter, but he don't want to talk very details.
One concern here, maybe they addressed it. So is that if we get arbitrary patch, this patch may introduce some unnecessary modification. For example, there's a refactoring committed along with the bug fix, right? And also maybe we fix it when we added some new code. So in this case, we need a very clean way to isolate the fix operation for the training. So this is probably about the cleaning issue.
Yeah, maybe there's some issue in the data cleaning, but we don't know.
Okay, go on.
Okay, so then is the experiment result. Here is 2 examples that fixed by this model called the Decoder. And the first example is a bug that the previous model failed to fix. The correct patch only changes a parameter of the method invocation. And the second, the figure 10 shows a bug only repaired by this model. This patch relies on a project-specific method called is no type, and this model can fix this bug. Okay, and here is the comparison without perfect faulty location. That means he just used a tool to locate the faulty statement, but not actually know where is the faulty statement. And you can see this model Decoder get the better result and gets the best result. Okay, and the conclusion is that Decoder repairs 53 debugs, achieves 26% improvement, and so same as on other standard data set. Okay, and if you use the perfect faulty localization, that means your training data set knows exactly which statement is faulty. It will get a much more greater result compared to the previous. You can see it will much more improvement. Okay, and here is the complementary. I think this is a good way to compare different models. This paper compare with different baseline model, and they found that these are the unique. These are the unique example this model can fix. But I also found that some unique example other method can fix. So maybe a combined method would be better. Okay. And this is ablation test. And from ablation test, you can they respectively remove the 3 edit operations: modify, copy, and insert. As well,
I think this experiment does not necessary. So the word is more diversified operation is support better, right?
Maybe he just want to show that he uses 4 innovations, and that it will be better because these 4 innovations.
Yeah, I can. Okay, let's skip this one.
Okay, so it also tests the the adequacy of the training data set. If you use more data set, this more large data set, it will get a better performance.
How do you look at the performance?
It used the loss because the loss is decreased.
Okay, the loss decrease here.
Yeah, and here is the takeaway. So the most innovation is a different decoder and use a placeholder generation. So it can fix the bugs before the past method can't fix. That's all for today's presentation. Thank you.
Okay, thanks, Yufan. So this presentation is good. So one of the hints is that I have the Prof. Phase movement, and according to his movement, this paper almost get the distinguished paper in FSC 21. So, but anyways, I think there's criticisms for this paper. So definitely this paper get a very high score for FSC this year. So my question here that if you are a reviewer, but anyway, anyway, this is a good paper, especially it embeds some, incorporates some considerable novelty here. So my question is here, if you are a reviewer, if you want to criticize it, so how, what do you think the negative point here? And what does this paper missing?
Do you mean?
Yeah, if you want to criticize this paper as a reviewer, and how do you criticize it?
I think the most important thing is, since the decoder is a bit easier, so I don't think it's very complex decoder, and however the encoder is quite complex. So it's my feeling.
Okay, is Xiaoling there? Oh, Xiaoling.
Yes.
So if you are the reviewer, if you want to criticize this work, and how do you criticize it, and what do you think there's an unsatisfying aspect for this work?
The problem is I didn't follow.
Didn't follow, right?
Yeah.
So again, you will get a borderline.
No. Because I'm not familiar with this part. So
and Dr. Xiaoyan, what do you feel?
I might ask a question about, for example, the time consumption, and because I didn't see anything about this, whether it is getting complex or simple about the decoder.
Efficiency problem. You think so? Introduce a more complex architecture, it may incur the runtime efficiency problem. So this is your point.
Yeah, and the second one is I might ask whether the rules they proposed are enough or not. Because how can of course it depends what they describe their rules. But as I will also ask such question whether it is enough.
Okay, so
I think they can't generate new code for my understanding. They just replace replace the variable name, or just copy from other contexts. I didn't see any example to generate some quite new code. Oh, yeah, maybe this is a problem, but I'm not sure.
So if I were the, please.
So basically he just generates the two statement, because this is the HL statement. The HL statement is, I don't know, maybe it's if else, or like for a while, I don't know, maybe this statement, but I think it lacks flexibility.
So here the question that the HR statement is a synthesized statement or a dual copy paste, and what is the rule for HR statement? Is there a rule for just HR statement?
No, it's not specified, because
so here if it is HR statement, it means that we can insert an arbitrary method invocation here, right? Because method invocation is a method invocation statement. So it's quite flexible, and I don't know how to synthesize the code in this work. But since it is a HL statement, I can replace it as a Java statement or Python statement. It could be anything, right? So based on their definition, I don't know how they implemented it, but from the theory perspective, this HL statement could be everything. It could be a new. It can be a newly synthesized statement. May or may not be copied from context.
But here he said is I don't know. He said is non-terminal in the grammar of the host language. So
Yes.
Based on the grammar, so maybe it's just some if else or for while.
Yeah. So the point is the grammar because so here is BNF for addition, right? But for Java, there's still a BNF to describe what a Java language is, or there's still a BNF for what is Python programming language is. So as long as based on that description, it's going to synthesize the new Java or Python statement.
Okay.
Right. So I think all of us will make a point, but if I were the reviewer, I will raise two questions. The first question is still a minor question, is that it has assumption that the fixed location has been known, but anyway, fixed location is a challenging progress, and how to predict where to insert the statement is very important to me. So if we only assume there's a fixed solution, but we miss a good fixed approach, the whole approach seems incomplete to me. But the good thing is that the authors provide experiment to showing with existing state-of-the-art fixed location tool and what is the overall performance. So anyway, my concern will be addressed here. My second concern lies in the information used for synthesize operation. So given the piece of code, this piece of code can be a feature in one project, but can be in one project, but it can be a bug in the other project, right? It's purely whether the piece of code is buggy or not, purely based on the project requirements. So in this project, if I'm the reviewer, I would like to the authors to generate an assumption or precondition when this technique can be applied, right? If it is for a project-specific piece of code or project-specific bug, and this approach may not work, presumably. But if it is general bug, for example, we miss if else for non-check, this approach might work. So a better approach would be we have a checker, maybe Dr. Xiaoyan, you can use your self-checker to apply it on their approach to see, given a piece of code, whether this model can be applied here. So if it's not okay, we will not apply this approach. We'll not fix this. So this is another concern I have. But overall, it's a good paper, especially the novelty of generating rules. And it also involves some very solid engineering work there.
Yeah.
Okay, so that's all for my comments. Is there any questions for this paper?
There's a small proof of how these rules applies, how this rule can apply all the statements in the paper. But I think it's quite not very convincing, so I didn't pick it up. So maybe if you're interested, you can check the proof.
Okay.
Yeah.
Okay, so yeah, I think both Ruofan and Yufan have given a very clarified presentation, and maybe we can call it a day if we can call it a day if there's no questions. Okay.